For centuries, the asteroid belt was imagined as a collection of cold, lifeless rocks drifting silently between Mars and Jupiter. Most astronomers believed these ancient objects had changed very little since the birth of the solar system. But one mission would completely transform that picture. In 2007, NASA launched the Dawn spacecraft with an ambitious objective: to visit two of the largest objects in the asteroid belt and uncover clues about how the early solar system formed. Unlike previous spacecraft, Dawn relied on advanced ion propulsion, allowing it to orbit one destination before continuing to another. This technology made it one of the most efficient deep space missions ever flown. Its first stop was Vesta, a giant asteroid scarred by enormous impacts that revealed the violent history of the young solar system. After completing its investigation there, Dawn continued toward an even more mysterious destination. That destination was Ceres, the largest object in the asteroid belt and the only dwarf planet located between the inner and outer planets. Although Ceres had been discovered in 1801, astronomers knew surprisingly little about it. Through Earth-based telescopes, it appeared only as a tiny point of light. Everything changed as Dawn approached in early 2015. The spacecraft slowly transmitted sharper and sharper images, revealing mountains, deep craters, and an ancient surface shaped by billions of years of impacts. Then scientists noticed something extraordinary. Inside one enormous crater were several brilliant white patches shining far more brightly than the surrounding landscape. Against the dark gray surface of Ceres, these features almost appeared to glow. At first, researchers weren't sure what they were seeing. Some proposed exposed ice reflecting sunlight. Others suggested unusual minerals. A few wondered whether strange lighting conditions had exaggerated their appearance. As Dawn moved closer, however, the mystery became clearer. The bright regions were real. High-resolution images showed that they consisted of highly reflective deposits concentrated within the crater known as a crater. Spectrometers onboard the spacecraft revealed that these bright materials were dominated by sodium-rich salts left behind after briny liquid reached the surface and the water gradually disappeared into space. This was an astonishing discovery. Instead of being completely frozen and inactive, Ceres appeared to have experienced movement of salty water from beneath its crust. That possibility changed the way scientists viewed dwarf planets. The evidence suggested that Ceres may still contain underground reservoirs where water, salts, and minerals interact deep below the surface. Even more surprising, some observations hinted that faint hazes occasionally formed above parts of a crater during certain times of the day. Although researchers continue studying these observations, they may be connected to water vapor escaping from subsurface material as sunlight warms the surface. If so, Ceres is not simply an ancient rock drifting through space. It may still be changing today. These discoveries challenged long-held assumptions about small worlds. Rather than being completely inactive, Ceres showed signs that geological processes could continue long after a body's formation. The more Dawn explored, the more scientists realized that one of the solar system's oldest objects was also one of its most fascinating. And the greatest discoveries were still waiting beneath its surface. The more scientists examined the data from the Dawn spacecraft, the more Ceres refused to fit the image of a frozen, inactive world. Instead, it began to look like a place that still possessed a surprisingly dynamic interior. One of the biggest questions became simple but profound. How could such a relatively small world remain geologically active after more than 4 billion years? Researchers believe the answer lies beneath its rocky surface. Unlike many asteroids, Ceres appears to contain large amounts of water ice mixed with minerals and salts. Deep underground, these ingredients may form pockets of dense, salty liquid known as brines. Because dissolved salts lower the freezing point of water, these brines can remain liquid even in extremely cold conditions. Scientists think that ancient impacts fractured Ceres' crust, creating pathways through which these underground fluids slowly rose toward the surface. As the liquid reached the vacuum of space, the water quickly evaporated, leaving behind brilliant white salt deposits. Those reflective minerals are what make the bright areas inside a Keter crater stand out so dramatically. The process resembles a form of cryovolcanism. Unlike ordinary volcanoes that erupt molten rock, cryovolcanoes release icy mixtures of water, salts, and other volatile materials. Similar activity has been identified on icy moons such as Saturn's moon Enceladus and may also occur on other distant worlds. The possibility that Ceres once experienced cryovolcanic activity makes it one of the most unusual objects in the inner solar system. These discoveries also changed the search for life beyond Earth. For many years, scientists focused primarily on planets with warm surfaces and liquid oceans. Today, attention has expanded to include icy worlds that hide water beneath their crusts. On Earth, microscopic organisms survive in deep underground environments, beneath glaciers, and inside salty lakes once considered too extreme for life. Those discoveries encourage scientists to ask an exciting question. If liquid water, minerals, and chemical energy exist beneath the surface of Ceres, could similar environments have existed there for millions, or even billions, of years? At present, there is no evidence that life exists or ever existed on Ceres. However, the ingredients that scientists consider important for habitability appear to be present, making the dwarf planet an important target for future exploration. Ceres has also helped researchers better understand how planetary bodies evolve. Rather than following a single path, worlds across our solar system appear to develop in remarkably different ways. Some become rocky planets. Others remain icy moons. And some, like Ceres, occupy an unexpected middle ground, small enough to resemble asteroids, yet complex enough to display geological activity. Although the bright spots first inspired dramatic speculation online, years of careful analysis have shown that nature often creates features that seem extraordinary without requiring extraordinary explanations. The brilliant patches are best explained by reflective salt deposits left behind by ancient briny material. Even so, they remain one of the most fascinating discoveries made by the Dawn mission. When Dawn finally exhausted its fuel in 2018, mission controllers ended operations, leaving the spacecraft in a stable orbit around Ceres. Its mission had come to an end, but the enormous collection of scientific data continues to shape research today. Every image and measurement helps scientists piece together the history of one of the solar system's oldest surviving worlds. Ceres reminds us that exploration often leads to discoveries we never expected. A dwarf planet once dismissed as little more than an oversized asteroid is now recognized as a world with a rich geological history, hidden chemistry, and the potential to teach us how planets evolve. The greatest lesson from the Dawn mission is not that we found something artificial. It is that the universe is capable of producing wonders far beyond our imagination. And sometimes, the most remarkable discoveries are the natural ones that challenge everything we thought we knew.